Next to the law of sines, there is also the law of cosines. So for the same triangle, so we have a triangle A with opposite angle alpha, B with opposite angle beta, and C with opposite angle gamma. For those, we get the following formulas. A squared is B squared plus C squared minus 2 times BC cosine of alpha. B squared is A squared plus C squared minus 2 times A times C times the cosine of beta, and C squared is A squared plus B squared minus 2 times AB times the cosine of gamma. So what we see here is that we have a relationship in which all three of the sides play a role and one of the angles. So the law of sines had 2 angles and 2 sides. Here we have 3 sides and 1 angle which come into play at the same moment. How to prove this? We will prove the first formula, and the other 3 are very similar. They are just changing the letters. And for each of them we should distinguish between 3 cases. So case 1, the angle alpha is smaller than 90 degrees. So we have a triangle where alpha is smaller than 90 degrees. So we have a sharp angle here. And now we have the same beta and gamma, A, B, and C. To do or to prove it, we again take the perpendicular distance, so the height h in this case. And now we will name this side. So C, we will split C in x and in C minus x. So the left part is x, the right part is therefore C minus x. So we now have created 2 right-angled triangles, and we will be using the properties of a right-angled triangle. So for this gray one, we can use the Pythagorean theorem. So we know that x squared plus h squared is equal to b squared. Furthermore, we know that the cosine of alpha, so the cosine was the adjacent divided by the hypotenuse, so it's x divided by b. Rewriting this gives me x is equal to b times cosine alpha. So this is my first formula, my second formula. And then we move on to the other triangle. So we move to the blue right-angled triangle, this one. And for this one we see that c minus x squared plus h squared equals a squared. So just to be clear, this is the letter A, the side A. If we then work out the squares, we find that a squared is c squared minus 2 times c times x plus x squared plus h squared. If we then use the equations 1 and 2, we get the following. So this equals c squared minus 2 times c times what we saw here in equation 2, b times cosine alpha, plus, and then we use equation 1 to change x squared plus h squared into b squared, so this becomes b squared. And finally we find that a squared is b squared plus c squared minus 2 times b times c times cosine of alpha. So this is basically what we had to find. If we then want to complete the proof, we have to consider 2 more cases. So case 2, alpha is larger than 90 degrees, so alpha is an obtuse angle. And case 3, alpha is equal to 90 degrees. The easiest one is case 3. So case 3, this is just Pythagorean theorem. Why? Because the cosine of 90 degrees is 0, and so that term is deleted. For the case with the obtuse angle, you basically do the same thing as in case 1, but your triangle looks a little bit different. So this will be alpha, but you do the same. You take this line as the height, and then you use similar formulas to prove case 2. So try to prove case 2 by yourself. And then if you have that, then you have to do the same thing for the second and the third equation of the law of cosines. So as I already said, in the law of cosines, in one of the equations you always have three sides and one angle. So let's take an example. What can we do with it? Well, we would have, for example, a triangle like this. And we know the sides, all three sides, 8, 5 and 12. And now we do not know any of the angles. Because we know the three sides, it's easy to find the angles using the theorem. So we know by the theorem that a squared is b squared plus c squared minus 2 times b times c times the cosine of alpha. So this means that cosine of alpha is b squared. B was 12, so 12 squared. Plus c is the opposite of gamma, it's 8 squared. Minus a squared, so minus 5 squared, divided by 2 times b times c. And so cosine of alpha equals 0.95. And this gives me an angle alpha of approximately 18 degrees. Similarly, you can find that beta is approximately 29 degrees and gamma approximately 133 degrees. Because in this case we are working with a cosine, you will see that in practice you normally have no ambiguous cases. Knowing the law of sines, the law of cosines, try to solve the following problems. So the first problem, we have a triangle. So in a triangle, we know that the side B is equal to 2 times square root of 3. The side C is 3 times the square root of 2. And the angle gamma is equal to 60 degrees. The question is, find alpha. For the second problem, we know that in a triangle, the three sides have a certain proportion. So if A relates to B relates to C, as 4 relates to 5 relates to 6, prove then that the greatest angle is the double of the smallest angle. So if your sides relate to each other as 4, 5 and 6, prove that the largest angle is 2 times as large as the smallest angle. So the goal is that you first try to solve these problems yourself before taking a look at the solutions on the following slides. Let's take a look at the first problem. What do we know in this problem? So we know the side B, we know the side C, and we know the opposite angle of side C, the angle gamma. So what we will be using is the law of sines, because we know two sides and one angle. So in this case, we know that sine of beta over B is equal to sine of gamma over C. And with this, we can find the angle beta. So sine of beta is B times the sine of gamma divided by C, which is 2 times the root of 3, times the sine of 60 degrees is root 3 divided by 2, divided by C, which was 3 times the root of 2. So if we simplify this, we see that we have root 2 divided by 2. And so the beta will be equal to either 45 degrees or to 135 degrees. As we already mentioned before, we now have to check, are both of them possible? Is this a possible solution? Well, if beta is 135 degrees, and we know that gamma is 60 degrees, then we know that the sum of those is already 195 degrees, which is larger than 180 degrees. And so this is not a valuable solution. So the only solution we have is that beta is 45 degrees. And if beta is 45 degrees, then we also know alpha, because alpha is 180 minus 45 degrees minus 60 degrees, which gives me 75 degrees. For the other problem, we know that the side C is the largest. So C is largest side, which we know from this relationship. If C is the largest, then if you just look at the triangle, you also know that the opposite angle will be the largest. So gamma will be the largest angle. And we see that side A is the smallest side, which means that the angle alpha will be the smallest angle. To solve this, we will give values to each of the sides. So we don't know the sides themselves, but we know their proportions. So we say that side A is 4 times k, the side B is 5 times k, and the side C is 6 times k, where k is some unknown constant. Since we know 3 sides, what we will be using is the law of cosines. We need to get some information about the angle alpha and the angle gamma. So what we will be saying is that a squared is b squared plus c squared minus 2bc cosine of alpha, and c squared is a squared plus b squared minus 2ab times the cosine of gamma. In that case, we get that cosine of alpha is b squared plus c squared minus a squared divided by 2bc. Cosine of gamma is a squared plus b squared minus c squared divided by 2ab. And now we can plug in the values. So we know b is 5 squared plus 6 squared minus 4 squared times k squared divided by 2bc. So b is 5 times 6 times k squared. Similar here, we plug in the values. A squared was 4 squared plus 5 squared minus 6 squared times k squared divided by 2 times a times b. A was 4, b was 5, we get a k squared, a 2, and I forgot 2 here. If we now work this out, if we calculate it, we get 45 divided by 60, or 3 over 4. And for this one, we get 5 divided by 40, which is 1 over 8. Thus, see that the cosine of alpha is 3 over 4. We see that the cosine of gamma is 1 over 8, which already proves that alpha is smaller than gamma. Why? Because my cosine is larger, so it means that my angle alpha must be sharper than my angle gamma. So alpha is smaller than gamma. We now still have to prove that it is twice as small. For this last part, what we will be using is the double angle formula. So we will be using cosine of 2 alpha is 2 times cosine squared of alpha, because we know the cosine of alpha, minus 1. This is 2 times 9 over 16 minus 1. So it's 18 over 16 minus 16 over 16, so it's 2 over 16. It is 1 over 8. So it's equal to the cosine of gamma. Hence, we have shown that 2 alpha is equal to gamma, and so alpha is half as large as gamma, what we needed to prove.